But I do want to go ahead and look at page 143 in your books. Hopefully some of you guys have been working on this already. Yes, ma'am. Yes. So when we're talking about the work here, there's a claim being made. Do you guys look, can you see the TVs there?
Yeah.
What claim are they making? Similar to these types of claims?
The 80-inch TV is more than twice the area.
Yeah. Here, the claim is that the 80-inch TV has more than double. So more than double the screen area of the 55-inch TV. You guys okay if I use the abbreviation for inches? That's what those two little marks mean. I don't know how you guys are with the inches and the feet little marks. It took me forever to figure out which one was feet and which one was inches. I kept getting them confused because my brain said one mark is less than 2 marks, so one little mark must be for the smaller unit of measurement. This is not true. What finally helped me remember which went with which was the number of syllables in the words. Do you guys remember in elementary school having to clap out syllables? Did you ever have to do that? Yeah, exactly. Inches. 2 little marks for inches because you have to clap twice on that one. 1 for feet. That's the only way I was ever able to remember which was which. And it's stuck with me ever since then. All right, so there's our claim. We have an 80-inch TV and a 55-inch TV, but then they're talking about area. How do we find area of rectangular objects like televisions? Multiply the length and the width. So why do I only have one number to work with?
Because that's the length of the TV.
Is it? Do you guys know how they measure TVs?
No.
Diagonally. They measure the absolute largest figure they can get in a single unit of measurement on television. They measure it diagonally, from upper corner to opposite lower corner. Doesn't matter which way you go, it should be the same either way. So when they talk about an 80-inch TV, one corner to opposite corner. Same with the 55-inch TV. They can get away with this because televisions all have the same, what they call aspect ratio. If you ever watch an old movie, like something that was taken from way back when your parents were kids and growing up and the televisions were different shaped, they were more square shaped. If you watch a movie that was made for that size television, there's like the blacked out pieces on the sides because it has a different aspect ratio. They all have the same aspect ratio so that when they broadcast television, when they put out movies and whatnot, it looks the same on everybody's TV. You don't have somebody with like a really wide head because it's stretched it out, or really skinny people, or a bunch of dead space on your television. People don't want to pay for an enormous TV only to watch this much of it, right? The aspect ratio, and feel free to double check me on this and Google it yourself if you don't believe me. The aspect ratio for TVs, the industry standard, is 16:9. And I found that up by looking it up myself. Do you guys know what an aspect ratio of 16:9 means? These are the proportions of the width to the height. You know how televisions are usually wider than they are tall? So if we had a very small television that was, say, 16 inches across the bottom, how tall would it be? 9 inches. That would be a very small television. 16 inches is only about this big. It's just barely over a foot. It's not even a foot and a half. 9 inches is only about this. So you're talking about something like this big.
That's a tablet.
Exactly. Nobody buys a TV that size. But this is the proportion, the ratio of all of the TVs. So, for example, if I was looking at a television that was 32 inches across the bottom, how tall would that TV be? How much? 18 inches. Can anybody tell me how Edgar figured out that if it was 32 inches across the bottom, it had to be 18 inches tall? That's exactly right. If you multiply the bottom number by 2, you have to multiply the side number by 2 also. If you multiply the bottom number by 5, you would have to multiply the side number by 5. It changes proportionally. However many times you multiply the bottom, that's exactly the same thing that you would have to do to the height. We have this 80-inch TV. I'm going to draw the diagonal in here. Does it matter which way I go with it?
No.
Nope. So I'm going to draw it this way. What should I label it as? 80 inches. I don't know how wide or how tall this is. Why do I care about figuring out how wide or how tall it is? Yeah. What is it that we want to know about these two TVs that we're trying to compare? The area. To compare the area, I need the length and the width so that I can multiply those together. I don't have the length, I don't have the width, but I do have this aspect ratio. And between the aspect ratio and the diagonal, I can figure out the length and the width. We said over here, this aspect ratio means whatever I multiply the bottom by, I have to multiply the side by the exact same amount, right? So I know it has this relationship between 16 and 9, but it's not just 16 inches and 9 inches, right? If I have to multiply both of those by the same amount, but I don't know what that amount is, what could I call it? X. So 16x and 9x. Because whatever x is, I multiply it to both of those, and that would give me the correct length and width, right? Yes? No?
Maybe.
Awesome. 99, 100? I want you guys to look very carefully at what shape we just made.
Right.
Specifically, what kind of triangle?
Right.
Right triangle.
Right triangle. What's special about right triangles?
90 degrees.
90 degrees. What can I use with right triangles that I can't use with any other kind of triangle?
Angles.
Pythagorean theorem. There's special relationships with the angles too, but specifically on this I want my length and my width. So I'm looking at sides. That's why I'm thinking Pythagorean theorem. So I've substituted in a couple things already. You guys okay if I change the screen? Okay, because that'll get these substitutions up a little bit higher. But basically when I'm looking at a triangle, one of those sides is A, one of those sides is B, but the hypotenuse, that diagonal, is always what? C. So we do A squared plus B squared equals C squared, and I have gone ahead and substituted those pieces in. I let this be the 9x side, and this be the 16x side, and then that diagonal is the 80. I went ahead and simplified the left-hand side in that first step already. How did I go from 9x with parentheses and a squared to 81x squared? How did I go from here to here? Distributed the squared. What does it mean for something to be squared? Times it by itself. So we did 9x times another 9x. 9 times 9 gave me 81. And x times x, well, something being squared means to multiply it by itself, right? X times x is multiplied by itself, so that's that x squared part. Same process with the 16x times another 16x to get 256x squared. What would I have on the right-hand side? 6,400 from doing 80 times 80, right? 81x squared and 256x squared, those are like terms. Why? Exponent's the same, variable is the same. The only thing that's different about them is those coefficients in the front. So we're going to combine them. Combining always means to either subtract or add. We're not multiplying anything, so my exponent won't change. Exponents only change because it means to multiply it by itself. We're not multiplying things, so that stays x squared. What do I get when I combine the 81 and the 256 together? 337. So I have 337 x squared equals 6,400. I'm sorry.
So the exponent wouldn't change, right?
Correct. Exponents change when we multiply. Because exponents mean how many times you multiply it by itself. So the only time they can change is when we are multiplying things.
Other than that, they stay the same.
Exactly.
We would be multiplying the exponents by itself, right?
If this was 81x squared times 256x squared, I'd have x squared times x squared. That would change my power. But because it's plus, that doesn't change. What would I want to do from here as I try to get x by itself?
Subtract, divide 337.
Yes, we're going to divide both sides by 337. And this is where it starts to get messy because that does not come out to a nice, pretty whole number, does it? You said 18.99? How do we get rid of the x squared part? Not divide. Square root. I don't divide because I would have to divide by itself. It would have me dividing by x, and I don't know what x is. That's why I can't use division here. But I can take a square root of both sides. What is the square root of 18.99? 4.357. This is what we multiply the 16 and 9 by. So when we're talking about that aspect ratio of 16 by 9, if I double the bottom, I double the height. If I triple the bottom, I triple the height. This is going to be a little bit more than 4 times the bottom. So it's a little bit more than 4 times the height there. So what do I want to do with that 4.357? Put it into those parentheses there. This will give me the length and the width of this television. What would we get? 69.7 for the bottom? Okay. Would that have units with it? It would be inches. What about the width or height? It doesn't really matter what we call it. 39.375, and that would also be inches, right? Hold on. I'm seeing some faces, so I'm going to grab my calculator and double check too. We're going to do 4.357 times 16, 69.7, 39. I got 39.213.
Yeah, I did 375.
Oh, got it. I do that all the time. 213 inches. Do you guys understand what I've done so far?
Yeah.
And how we came up with those numbers? So just reading the ad at home, knowing what the aspect ratio is and the diagonal, I could take it and figure out whether or not it would fit on my wall without having to go to the store with my tape measure. How can I find the area of this now? I'm sorry, Gianni, do you have a question?
It was like a shrimp kind of statement. I really like that homework that we had on Tuesday.
Mm-hmm.
Like, it was really easy. That's like the first time I ever tried to do any homework. And it was really nice.
And you like that one? Good.
And I did good, too.
Good. So how are we going to find the area of the 80-inch TV? Yes, we're going to multiply those two together. 69.7 inches times 39.213 inches.
That's 27, 32.42.
Yep. 27. I got 3. I'm going to round this to 15. Is that okay?
It's for the number 4, right?
Yeah, I just don't have much room down to bottom for number 4. What units would that get? Inches squared. How do I know whether it's inches or inches squared? True. Do you know why? Yeah. 5 times 5. What would be another way of writing 5 times 5? 5 squared. X times x. Another way of writing that would be x squared. So when I do inches times inches, I have inches squared. That's why area has squared units. Taking that just a little bit further, if we were not talking about area but volume, would it have squared units? Because we do length times width times height, that would have cubed units. Because I'd have inches times another inches. Or feet times another feet. So when we talk about volume or capacity, it gets cubed units. All right. I want you guys to spend the last couple minutes of class, and we'll go over it tomorrow. If you turn the page, we only talked about the 80-inch TV, right? We want to compare it to what? The 55-inch TV. Process is almost identical. What's the only difference? We're going to use 55 for the diagonal instead of 80. Other than that, the process that we walked through is identical. So I want you guys to look through this and calculate the length and the width so that you can find the area of the 55-inch TV so that we can determine whether this claim is true or false.
That's hilarious. Can you come back here, please?
Yep.